All right, so it's time that we start, 7:30. So hello, everybody. Welcome and good evening to all of you. Myself, Anshul Mathur, and I'm being accompanied with Preeti Seni. We both would be our speakers for the evening. On behalf of Test Backend Technologies, we would like to thank all of you who found our time this evening and have joined us on this journey, which is a fascinating one, to learn microservices testing. As you know, we have designed 3 sessions over a span of 3 weeks, where we will deep dive on churning out premium quality microservices testing, right? We'll learn on how to balance various testing activities that will help you do effectively the microservices testing. During these sessions, if you have any question, please feel free to put it on the Q&A forum that you see on your Zoom windows. We'll take up all the questions at the end. All right, so let's begin the first session, which is comprehending the quality strategy. So let's form our fundamentals of microservices testing in today's session. I'll start with the agenda for the day. We'll share a couple of interesting facts around microservices adoption. From there, we'll give a quick refresher on what microservices are. Then we'll deep dive into what makes microservices a more challenging environment to do testing, right? Then we will introduce the mantra for effectively testing microservices. Then we'll try to implement that mantra in form of a test pyramid, right? From there, we'll look at some of the major components which would help you build the right set of microservices quality strategy. At the end, we'll leave you with some of the takeaways and a glimpse of the next session. So let me begin. So I'll begin with a survey which was done by Solar.io some time back. Right? It's a very interesting fact. It says that 85% of the businesses have started migration of their infrastructure to adopt microservices in 2022. Right? So that's a big number. Now, why do you think so many businesses are looking into microservices as an option? Right? Let's look at some of the major reasons. Scalability. Microservices can be configured to auto scale dynamically whenever there's a change in the demand, right? A microservice can be implemented as well as mapped to containers, right? Which can horizontally or vertically scale whenever the demand rises or falls. This gives a lot more of scalability and agility to businesses, right? To microservices architectures. Next is security, right? Now, microservices systems, basically a platform built with multiple microservices, with each microservice can define their own set of authorizations and authentication mechanisms. Now, what does that mean is that any sensitive data, which is part of one of the microservice, can be safeguarded from access from the other components in the platform. So you have more control over the data flows. The next is versatility. Now, microservices architecture gives the teams to experiment. It's the freedom to try out new libraries, new technologies, right? Use them into one of the microservice, get the value and impact, right? Learn from it, and then cascade it to the other microservices in the system. So because of these 3 top reasons, a lot of teams have started adopting microservices. Let's look at one more survey, which was done very recently, a year and a half back by IBM. It basically took a pool of companies who've already doing microservices and tried to find out what are different benefits that teams get out of microservices. And the data is really interesting. 30% of such companies felt that their customer satisfaction have grown once they have moved to microservices architecture. Similarly, 29% of the companies felt their time to market, how fast they are able to put changes to customers' hands, have increased a lot. 28% of the companies felt that the quality of the performance have improved, right? We move to the next parameter, is greater flexibility, right? These microservices provide a lot more of flexibility to 27% of the companies. Similarly, there are 26% of such companies which see that their employee productivity has improved. Now, this statistics, what does this mean, right? The statistic is enough to prove that we need to deep dive into microservices, because that's the present and the future. So in this series of webinars, we will deep dive further into how do these microservices behave, right? What sort of test strategies we'll have to implement and what makes our microservices premium quality. However, before we get deep down into microservices, let's first do a quick refresher on what a microservice is. A microservice is an architectural pattern. Right? It's the way or the approach that you design your systems. Right? In this design, you basically break down a large application into smaller components. Now, each of these components may be called as a microservice. Each such microservice have a defined scope and objective. Let me take an example. Let's say you're building an e-commerce system. So one of your microservice could be called as a payment service. It takes care of all payment workflows. Similarly, there would be another microservice which takes care of the customer data, and you call it as a user service or a customer service. Similarly, shopping cart service, and so on. Right? Now, there are three very important characteristics of each microservice, which we need to understand thoroughly before we start writing tests for them. Which are these? Let's take one by one. A microservice should be independently developed. That means that you can have independent teams working on these microservices. Each team can have their own roadmaps and their own timelines. Right? Of course, it will be aligned to the larger goal, right? But they can still have their own plans. Similarly, a microservice should be independently testable. That means your test strategies can vary amongst multiple microservices, right? And which means variety of tech stacks, variety of test tools, and so on, right? More importantly, one microservice should be testable in isolation to other microservices or any other dependencies outside its own scope. Third one is independently deployable. Every microservice team should be able to deploy their changes on stage or production environments at their own pace, right? So their pipelines, their build promotion strategies could be different than other microservices, right? So with this refresher on microservices, let's go down to see how these microservice architecture is different and it makes testing a challenge. All right. So let me talk about some of the technical challenges that we see in microservices testing. Right. First of them is asynchronous integration. Now, microservices, they are built based on event-driven architectures. Right? Now, that means one of the microservice would publish an event when its own processing is done, and all the other microservices which are dependent on this data which is being published, they'll keep listening to such events. They'll fetch the data once the event is available, and then process it at their own pace. Now, think from a testing perspective. When you've written some automated tests, you would have some stipulated time in which you want to validate that the key entities in the system have got updated. However, with this asynchronous nature, these entities would definitely update, but they don't update immediately. They update eventually, right? So your basically your tests would start get timeout, while trying to fetch the right state of these entities. The next technical challenge is contract changes, right? Now, let's try to understand what a contract is. A contract is basically an agreement between two parties, or two or more parties, which governs the way they'll interact with each other. Right? In terms of a microservices platform, it's basically two or more microservices which have created their request and response interactions as a contract, which we call as an API contract, right? Which will govern the way they'll expect information exchange between each other, and they'll develop their own logic based on the contract which is predefined. However, the service which is providing that information, right, we call them as a provider, right, in the contract terminology, and the service which is using that information or waiting on that information is called as a consumer. So one provider can have multiple consumers. Right? That means that over a period of time, due to technological advancements or business priorities or changes, you might want to update these contracts. So there are two problems here. One, all your consumers need to know that there's a change which is happening in the contract so that they can accommodate the relevant changes in their own microservices scope. Second, we need to make sure that these breaking changes from the provider are validated so that none of the consumer starts faulting on a live environment. Right? So these contract changes are difficult to manage over a period of time. Next is feature flags. Right? Let me talk about what feature flag is. Right? A feature toggle is essentially a condition that you put in your code that, all right, if my condition holds true or my flag is turned on, some piece of code would be consumable by external interfaces or any other consumer outside that piece of code. Similarly, if you'll put that feature flag off or you turn the toggle off, basically you have the code ready, but it is not consumable. So microservices, they use this feature flag concept a lot to make sure that they are independently able to deploy changes, while the other portion of the same capability which they have built, which is kind of under scope of some other microservice, once only the other microservice or the dependent services are available with their code, only then they'll turn on these feature flags so that the end-to-end customer journey can be tested and can be made available. Now imagine where with many microservices working together, there'll be so many relationships between these feature flags, right? One feature flag turn off may create so much inconsistent behavior in the system. So we have to test feature flags in a way that we check the behavior of your system in both cases, when feature flags or toggles are off or when they're on, plus the relationship between these microservices feature flags. Next is test data creation and sustainability. This means that whenever you want to write a test for your microservice, you may have a data dependency on other microservices. Let's take an example of the same microservice we are talking about, right? Payment microservice. If you want to test that you're able to make a payment, there are two entities which you will definitely need. One, the product for which you are looking to pay, and the customer who is looking to pay. But both of them are basically part or entities which are governed or owned by another microservice and not your payment service, right? So when you have to test, you're basically dependent on generating data which is getting generated at some other service. So over a period of time, the data can get corrupted, right? Or for that matter, the data can be removed by the other microservice if they are facing certain problems with managing data, right? So you need to have a very consistent strategy of how do you manage this test data, which can keep your tests stable all the time. Finally, we come to difference in technologies. As I said, a microservice can choose to have a different sort of tech stack on which it is built, right? So your payment service could be built in JavaScript stack, versus your shopping cart or a customer service could be built in Java or a Python. So when you start testing, when you want to choose your test automation tools, right, it will be different based on the technology which is there for the microservice. Right? So you need to be versatile, right, and competent to be able to write tests for different sort of microservices. Now, from the technical side, we move to the process side. There are certain process challenges as well when we do testing for microservices. Let's look at them one by one. Mutual availability on live environments, right? Now, as I said, your microservices are deployed at different times, right? That means for us to test a customer journey end to end, we need multiple microservices to be deployed to a certain environment in a synchronized manner. However, because of their speeds and their own roadmaps and their developments, right, it is difficult to manage this mutual availability. So you have to make sure that there's a lot of coordination and communication between these microservices so that your testing is possible. Next is ownership of end-to-end. Now imagine you are part of a microservices team, right? You have a very clear goal, very clear objective, right? And very limited set of APIs to validate the behaviors, right? But nobody is thinking of the end-to-end tests, right? Let's say there are 10 different microservices teams, right? Each of them are doing awesome with respect to their own testing, right? But who would own the end-to-end workflows of the customer, right? So we need to figure out where would this end-to-end test go, plus who would take the ownership of creating those end-to-ends and maintaining them, or probably debugging if there's any failure. Right? Because it will otherwise pass on from one team to the other, and you'll never be able to figure out that who owns it. Next is building the right test parameter. Right? Now, when you have so many testing activities within a microservice, right? Traditionally, we have seen a test pyramid which says a unit test layer, a service layer, and a UI. But with microservices, you don't have a UI at all. So what we need to do is break down these unit and service layer tests in the pyramid into further layers so that we cover a holistic set of features from our testing. So it is very important, rather I would say it's the key thing with regards to testing a microservice. Are you building the right test pyramid? The next point is understanding product and customers. Now, when you're part of a microservice, it is very difficult to build the larger context, or I mean, as they say, right? Do you have the bigger picture? Right? How is your customer using your product end to end, right? And how is each microservice contributing to make that journey successful? So that sort of understanding is very difficult to attain only unless you have complete visibility across the scope of each of the microservice, how they're designed, what their scopes are, and then how do you connect each of them, like how they are integrating. All of that information you need to have to be able to build good understanding of the end-to-end product and what your customer demands. So these are some of the challenges, but however, we'll try to solve all of them during these sessions, and we'll move on to the mantra, right? So mantra, as in we want to introduce our approach that we have found working for us while interacting with a lot of microservices. Of course, I must mention that this mantra may not fit into your ecosystem as is. There could be alternative solutions to testing microservices. But this is coming out of the experience that we have built over time, and most of these have worked for us really well. So we'll share that mantra and we leave it to your wisdom that you use it according to your ecosystem. You customize and you try it out. So let me introduce what we really want to share as the mantra for testing microservices. It's not a new term at all. I'm sure most of you would have heard of this term called shift left testing, right? What is shift left? It's a prevention technique rather than a corrective measure. Right? So shift left testing essentially means that you pull up all your testing activities earlier in the software development cycle with the aim to improve the overall code quality and reduce the number of bugs which are leaked. This means that you want early feedback, right, as early as possible so that the cost of fixing those problems is less, right, and you churn out good microservices faster. Now let's see how this shift left testing would actually work, right, for us people from QA community, how we should look this shift left testing at. Testing requirements, right? I mean, most of us will not through the requirement phase in general, right? However, if you have to be very effective into microservices testing requirements is a phase basically where you have to validate that are the requirements getting rightly captured between the business and your engineering teams, right? There would be so many acceptance criteria that the business would create, right, or the product would create, right? Are they getting translated into the right sort of technical user stories for the devs? If that is not happening, right, you will basically have a flaw in defining the scope for the problem, and eventually have defects which you have not even coded for. I mean, you've not implemented something, and then you'll find out, oh, we missed this scenario. So make sure that you get yourself involved in the requirements level itself. Make sure that the teams are gelling well, the communication is clear, and everything is documented that well, so that conversion of your requirements into code is basically smooth. Which brings me to the next point, which is now is this time when you start testing the code, right? Now, by code, I mean the application of the source code, right, of the microservice. Now, the moment a developer starts converting your user stories into code, that is the time we hit the quality, right? That is the time we make sure that the code follows the standards, the code covers all the use cases, right? Hence, we focus on the source code itself. Next is testing integrations, right? Now, your microservice would integrate with so many outside components, right? Like for example, you have your databases, you have your queues, you have your buckets on the cloud, you would have other microservices, and then you would have third-party integrations as well, right? So now all these different integrations together form your system, right? But if you're testing whole system at once, we may have to debug and spend a lot of time to figure out which integration is not working. So one of the best practice is to start testing these integration points individually, right? Is my data flow working right with my database? Is my queue getting flushed out at the right time, right? Or is my third party returning me the right sort of values on which I can build my responses? So to start looking into integration testing a lot more, all right? The next is testing the builds, right? This is when your code has reached a live environment, like, QA environment or a staging environment, you get a build to test. Right? So this is where you start writing some sort of black box tests, which will validate that when everything is wired up together, right, it works. So you figure out some critical scenarios, which you need to make sure, I mean, because, every environment can have, its own issues. So you definitely want some sort of testing to be done at the build level or at a test, at a live environment level, right? But because you've already made sure that your code is, built right, your integrations are tested, you've not missed requirements. So the intent of this this phase is essentially to make sure that everything is working fine together. It's not to find a lot of defects at this point in time. The bugs would have already been found out and fixed by now, most of them. Finally, you start testing on prod, right? I mean, you would have heard a lot of teams now do testing on prod. I mean, there are arguments like, oh, we have so many alerts, monitoring and everything available, right? But still, for gaining a lot more of confidence on, your code, plus getting informed about a problem on production before a customer reports it. So you run some lightweight production test suite, right, to make sure that everything on production is right, because you have real data, real customers, real workflows there. So you cannot really afford to be informed by a customer that your system is not working, right? So we have to do everything possible to know about a production issue before anybody else does. So this essentially is what shift left testing means, right? Now let's see how this shift left testing is actually converted on ground in the right set of test pyramid, right? And we'll see how different layers in your pyramid would help you build the right sort of model for shift left, right? I'll pass it on for this to my colleague, Preeti. All right, over to you, Preeti.
Sure. Thanks, Anshul.
I'll make you the host now.
Okay, just give me a minute.
Sure.
Right, you can make me the host now.
That's done. Go ahead.
Right. Right. So, Anshul, can we move to the next slide? Yes. As we were discussing, right? So the shift left mantra could be implemented very effectively onto the test pyramid. And if your test pyramid is not effective, then you might not be able to reach the shift left stage that we have been discussing and that Anshul was mentioning in the right slides, right? So on this pyramid, we'll start with the bottom layer, which plays a major role, which is nothing but the linting and the quality gates on your PRs. These accounts as a static checks that we add, which helps in identifying the code smells and if the teams are following the right coding standards which is being set for the teams, and if the code formatting is correct. So there's a lot of tools that teams use that goes through your source code line by line and helps you giving these results out in an early phase. You could use these in your local, as well as you can integrate with your PRs and see that only the good quality code is always being merged, approved and merged. So these two also helps in a lot of helps the code reviewers, because it takes off this burden and they can actually review the logic, the implementation logic and the modularity of the code. So linting along with enabling the quality gates of your PRs does helps a lot. Also helps in maintaining the internal quality of your source code. So moving on to the next is the unit test that we have been hearing, right? Unit tests have been in the market for quite some time, but unit test does helps a lot in maintaining the internal quality again of the source code. And for the microservices, it becomes must eventually when you're looking for early production releases, where you're looking for weekly once or more than once. Investing on the unit test could be very effective here. You could identify early issues on in your build stages itself, and use a lot of mockings. There are frameworks available on in the market. Along with that, it's an addition that we're doing is imitation testing. I wouldn't say it's a must have, but it's a good to have, right? Because unit test we have tools that identify what's the coverage of your unit test. It's a good strategy to see that unit tests are being written, but unit test coverage can be illusional at times, because it only helps you to see that if your test has run through those lines of code, but your test is is what assertions makes it. So if you have not added the right assertions, your test might not be able to find the right bugs for you. And that is where the mutation testing helps you to identify whether you have written the good quality unit test or not. And having a combination of unit test and mutation testing tools can give you can be very helpful for your team. So moving on to the next layer, which is the contract test, right? In microservices, when they are mesh of microservices, the only the only constant is a change, and the contracts changing is also very often and very known phenomena there. So keeping consumers and providers always on sync also becomes tedious, and contract test plays a very important role here. And it actually ensures that you know any changes in consumers are not against what is being agreed earlier in the contracts, and provider is not also providing any breaking changes to its consumers. And testing these early could be, again, helps you to identify those issues as early as possible, even at the build times. We are not reaching towards where we're saying that these tests are running at a deployment stage. No. So these tests, what we're looking at now are, if you run in your build pipeline, which gives you the results then and there, you can get early feedback in case if there is a failure. Now moving on to the next layer of the pyramid are your integration test. So now let's say within the microservices, we are, for a given microservice, we are verifying the internal quality through our static tools. We have unit tests, the contract tests are being verified to see that, the contracts are not being broken, and being a provider, I'm not providing any breaking change. The next segment that left is to verify the different components within my microservices are also working as expected or not. Any integrations with the external dependencies, be it other microservices or infra dependencies, are also working as expected. So these integration test helps you identify any issues at an early state, but also, when we look at integration test and verifying whether the dependencies of with dependencies, the code logic is working as expected or not, we might say that we might have to run these tests with the real dependencies. That is where we say no. As we've already discussed, right, your each microservice should be independently deployable and independently testable. So make these integration tests independent of your any dependencies. Make use of stubs and test doubles as much as possible, so that you can test your microservices in an isolation. And in case if there is any error, then you'll be able to confirm that this error is because of the issue within your microservice and not because of your external dependencies, right? So till the test that we are looking at, till integration tests, all these are nothing but your static checks plus the white box test. So that is where a lot of focus is now. What we are giving to is the white box testing, where you could actually test a lot into it, and even before your service gets into a deployable state. From here, once your integration test is also running successfully fine, right? That is where you move next to the level. And that is where we get a confidence. Yes, my service is working as expected and it could be built now. And let's see that if my other configurations and the authorizations, right? And when we're deploying to a new to other environments is also as expected or not, because that's the only part which is now missing. So, right, so that is where the service level test comes into picture. So the service level test gives you that additional confidence where it verifies against the real dependencies and ensures that your you and your dependencies are intact, and there is no issues in terms of whitelisting, or in terms of your not being able to reach out, or in terms of authorizations. So these service level tests actually you could keep as part of your that helps you to verify whether deployment has been successful or not. It could be also tied to your deployments on a later on. So till service level test is what we're discussing about a single microservice in the scenario. So when we move up a ladder, usually there's not only one standalone microservice, right? We have a mesh of microservices. So to gain the confidence that all the microservices in the mesh are working as expected, add end-to-end test which spans across these microservices and verifies that these services are stitched together and working as expected and giving you to the right results. Possibly, I would say, since these are microservices or mesh of microservices, if you limit your chest to the umbrella of these microservices would be really helpful, because all these microservices, if are following the similar pyramid, you would see that the issues that you find at your end-to-end test are going to be very, very minimal, and you could actually resolve them on a faster pace. And but that gives you a very good confidence in terms of whether your umbrella of microservices are working expected or not. And that is where you can also make a decision of moving on to a production deployments. And so the very top that sits are nothing but the production suites, which are nothing but the very basic test, which helps you to verify your production deployments are successful and there are no other issues in terms of authorizations or white box or whitelisting that you'll find there. So this is a combinations of tests that we have identified in the test pyramid. It has worked for us for the microservices that we have worked in the past, and possibly might work for you with a little tweak here and there, right? But also let's look into the other important factors. So as we move up the pyramid, right, the test complexity increases. So for example, for linting, we don't write any test, right? We're dependent on the static tools that we have. But the unit tests, those are very smaller. We have more control. These tests are not flaky. And even if there's a flakiness, could be addressed very easily. That goes to contract test. Integration test, because if you run these integration tests as part of your local host of your agents, right? So these also becomes, and you make use of stubs. So you can control your integration test and write more robust and resilient test. So, but as you move up where you are interacting with the real dependencies, that is where the game changes, where the test could be a little flaky. It takes time to address those flakiness, and even the test complexity increases, the test maintenance increases. And that is where we say that, so when you move up the ladder, maintaining these tests also becomes a costly affair. Also, the other factor is, as what we're discussing, right, the stability. So when the unit tests are the most stable test that we say, right? So then are nothing but a contract test, and then the integration test, and the stability decreases, and that is where you see that flakiness are also added. So to gain more confidence and to have more robust test and automated suits, so would say invest more on your white box testing and your static tools, so that would pay you off in the longer run. So moving on to the next slide, right? So since now we have seen the test pyramid, now let's see how the test pyramid is in action to attain that shift left mantra that we've been discussing, right? So in the build pipeline, so let's say we have these pre-flight checks that someone raises a PR. So it goes with those the phases in which we verify whether that we set up the dependencies. It goes through compilation. If there are any scripts that are being used in your test, in your source code, verify those scripts as part of it, right? And then is your code coverage that you could add to it that we were discussing. Also run the unit test, the integration test, and the contract test, all your static checks as well as the white box test as part of your PR builds. So that is where we say that, once you have these steps as part of a PR process, you get an early feedback. That means as long as there is a change happens in your source code, all these, the static checks are going to run, the white box tests are going to run. And in case there is a failure, you'll get an early feedback and it could be resolved then and there. It doesn't even, the service doesn't even go, moves to a deployable state. So have these checks as part of your build phase. And once your build passes, you push the artifacts and move it to a published plan, where you have the Docker image or a jar file is being published to a deployable state. Now and that is where, and then when you go to from here, when you move to a deployment state, it gets deployed to a, let's say, a staging environment or a QA environment, right? Where we verify whether the service is being able to deploy correctly or not. And then you run a basic automated test execution for, let's say, for sanity checks or end-to-end regressions to verify the last piece to gain the confidence whether all my authorizations and configurations are in place and there are no further issues encountered. And once you have all your and once you have the report generated, everything is green, and you can easily go for, you can make a decision whether you want to go live or, you want to wait on. So so these go live state, you could also have either a manual deployment, manually deployed, or you could also be configured based on the results that is being received from the automation test suites that runs in the end, which is nothing but your end-to-end test. Right, moving on to the next. So this is how the, in the last slide, as we have seen how the test pyramid works in your CI pipeline. So let's look into the other major components that we have in microservices, which are equally important when you are devising a test strategy. So first is the code coverage, and the next is the test stubbles, which is part of your white box. We will discuss more about these in the next slides. For the black box, we'll be discussing more about end-to-end regression and non-functional testing. And for monitoring, we'll also, operationals and monitoring will have, how to do the best practices around prod testing and when it comes to alerts. Right, so moving on to the code coverage. So as we were discussing, right, code coverage really plays an important role because your unit test sits at the bottom layer of your test pyramid. And if you have the right test identified and written, it gives you that extra leg up. So, but how do we identify whether we have the right unit test available or not, right? So that is where you could integrate with the external tools which are available that gives you the code coverage, and keep a minimum threshold to this code coverage as part of your PR as well, and as part of your project build tools like Maven or Gradle, where you say that if your code percentage is not more than this, you wouldn't allow for any merges to the master build, right? And these code coverage tools also gives you a nice snapshots on what lines of codes, what lines and branches are being covered, what lines and branches are not being covered. And that is where decision could be made there, whether these red lines also needs to be identified, the test needs to be written or not. Here is what you see, a snapshot from those code coverage tool like SonarQube that provides you, which says, what's your code coverage, how many tests are available, if there are any duplication lines, and what is the number of the duplicated blocks. So moving on to the next are nothing but the test doubles. Test doubles plays a very important role, right? Since we are giving more focus and attention to the white box testing, and we've been discussing about testing your microservices in isolation. So that means all the dependencies needs to be stubbed so that your microservice is tested in isolation, and if there are any issues encountered, could be because of your microservices. So that makes your test more robust. They would be very less flaky. It could be, the flakiness could be easily removed, and they could, and what you gain also is nothing but the execution speed, because the tests are going to run very fast, right? So when it comes to test doubles, there are 4 different kinds. They look similar when we look on the top, but there are very key differences. And based on these differences, you can actually identify, when to use which one. For example, mocks is when your dependencies are outside your test boundaries. Use mocks in that case. For stubs, use stubs when your external services or dependencies, right, are within your test boundary, so that you can also verify what request is being sent out, if the right authorization headers are being sent or not. The next is a spice, is choose spice if if you want to verify the behaviors and interactions, something that you are sending out to an external component like to a webhook or a queue, then you can make use of spice and verify the behavior instead of investing on a test, writing a test consumer and see what message is being received. Similarly, use dummy and fakes when for the if your infra dependencies are within your test boundaries. Like if you're using AWS stack, use local stack, and if you're using Azure, you can use emulators as part of these dummy and fakes and verify your test in microservices in isolation. So moving on to the next is end-to-end regression. So as end-to-end regression is part of your black box testing that we and these tests actually sits on top of your test pyramid that we have seen in this slide, right? But these could be also very costly affairs, because we would be verifying the mesh of microservices are working as expected or not, and hence there is a challenge of these are also challenge to write the right right end-to-end regression test, and in terms of in case if there are any issues, which team is going to fix it. So that is where the very first challenge that comes is what are the critical customer workflows that needs to be identified as part of these. Keep your end-to-end regression always very very small and very minimal, so that it's in case if there are any flakiness, you can easily address it, and in case if there's any maintenance needed, it could be easy for the team to fix it. But with time, if it grows, that is where it pains and cost a lot for refactoring. So the next is define an ownership model. Since we talk these end-to-end regression suits verifies the mesh of microservices. In case if there's an issue encountered, it gets difficult to identify which team is going to fix it, where the exact issue is. Hence, you have to come up with an ownership model from the beginning itself, so that it helps you ease it. Just give me a minute. The next comes is a feedback mechanism. In case if there is an end-to-end test failure, how soon could this failure could be passed on to the responsible teams to take the right actions, right? So that also needs to be set up before, and it helps you ease in maintaining your end-to-end regression suite. So now let's look like what's the general model of your end-to-end regression is nothing but usually have a runner or an execution runner that you use, which makes an API call to a proxy and a gateway, which internally routes the request to the mesh, mesh of microservices which is responsible, or one of the microservices in the mesh which is responsible for catering it. And once the response is received by the test runner, it takes an action on assert it, and it takes an action whether it's going to be pass or fail. But that's a generic model. uh, but then you have to invest a lot, do a proper strategy for your end-to-end regression suite on these three keys, which we just mentioned, right? The critical customer flows, and define a good ownership model, and how you're going to feedback. How do you send a feedback to the different teams in case of any issues are reported? So on the next components that needs to be discussed, I'll pass on the control to Anshul.
Yeah, thank you so much, Preeti. Would you make me the host, please?
Yes.
Just so that I could share my video.
Anshul, you can try now.
Yes, thank you so much. All right, thank you, Preeti, for the details of the pyramid and some of the major components. Now that, guys, we've looked into so much functional aspects, right? Non-functional is something which is equally crucial for microservices. Like particularly, I mean, whenever you're testing any backend, right? So many non-functional parameters that we should be looking to validate, right? Rather, I would first say set up some of the objectives for a non-functional parameters and then validate with some of your testing practices. So let's look at some of these non-functional parameters that are crucial for microservices. SLOs and SLIs. Now, SLO means service level objective, and SLI is service level indicators, right? Now, service level objective is basically a targeted measurement of a certain aspect of your microservice or your APIs. For example, you can have an SLO that says my service would be available 99.5% of the times. Or your SLO could be my API responses should not exceed more than 200 milliseconds till, let's say, 2000 users per second, for example, right? Then your SLIs are basically indicators which are the actual measurements of these parameters. So you run some tests, you capture these matrices, which basically are SLIs, and you compare or match these against your SLOs. Right? So SLOs and SLIs together, they'll help you devise the best sort of performance for APIs. All right. Next is there's certain signals which we call as percentile signals, P99, P95, P90, and all that, right? Now, what does these percentile signals suggest, right? A P99 signal means that 99% of our requests, right? What is the response for them, right? For example, my SLO could be that 99% of the requests that comes to my API, it should be responded within 200 milliseconds. So my P99 signal will tell me what is that remaining 1%, right, where we are faulting as a microservice. Similarly, a P90 would tell me that, how is my API responding to the 90% of the requests which it is getting, all right? Now, these signals together would help you find out what are the failure counts of some of these APIs, right? For example, your API starts returning a 5xx error, right? When it starts receiving more than 2000 requests in a second, right? So from a non-functional parameter aspect, we need to make sure that we regularly run some of these tests, right? Make sure that our API failure counts against our SLOs and P90 signals or P99 signals, they are intact over releases, right? All of these comes under a performance testing umbrella, right? However, there are a lot more parameters, right? Let me take you through some of them. One is vulnerabilities, right? What is vulnerability, right? It's the potential exposure of your system which could be attacked, right? So vulnerability scans, basically, there are so many static tools right now which are available, right? Which you can integrate as plugins to your source code, and they'll scan the entire code and find out what are the potential vulnerabilities, right? Probably some of the third-party libraries that you've used, right? They're vulnerable. So eventually, right, they may cause a breach on production, right? Or it may expose your system to unauthorized access and all. Right? So vulnerability scans are a very good medium to, identify these sort of vulnerabilities upfront in the static code itself. Next is authorization testing, right? As I said, different microservices can have different mechanisms of authorizing and authenticating. Right now, there are so many authorization mechanisms, right? You would have seen basic auths, you would have seen OAuths, the JWT tokens, and so much. Right? Now, we need to make sure that our APIs and our microservices are safeguarded against any unauthorized access. So we need to make sure that we are doing different sort of authorization testing for each microservice, given whatever is expected out of it. Another parameter is rate limiting, right? What is rate limit? It's basically the maximum number of requests after which is basically the acceptable rate of request for a microservice. For example, you can have a 25 requests per second rate limit, which means the moment 26th request comes in a second, your microservice will start returning an error. Now, this sort of testing would help you figure out that in case of a phishing or a spamming attack on your server, your service or your microservice or your APIs are ready, right? That they don't fall prey to such sort of attacks, right? So all of these comes under the security testing umbrella. Of course, there'll be a lot more of such parameters. For example, in performance, you would have volume testing, endurance testing, stress points. Similarly, in security side, you can have things like fuzzy logic testing, chaos testing, and stuff like that, right? But what is important to understand here is that we have to keep both functional and non-functional testing together in the purview when we create a test strategy for a microservice, right? So some of these parameters must definitely be part of your testing, right? And maybe some more based on your ecosystem. All right. Let me move to the next set of component that we have, which is alerts. Right? Now, alerts are basically supervision models, right? Supervising models. Now, what you want to do with alerts is essentially strengthen your process of tackling problems. Right, so you might have failures on stagings, you might have customer issues on production, you might have slow APIs on production, right? All of that. But how would you know about them? And only once you know, then you would try to debug and get that fixed. So as a quality assurance engineer on the project, right, we're not only bound by the kind of tests we are writing, but we have to strengthen the overall engineering, right? And that would include a lot more of such alerts, right? And let's see how we can implement some of these alerts in monitoring, right? We need to have some sort of a real-time trigger or alarms which are set. Let's say we use some of these, pager tools that will help you, whenever there's a problem, there's an error, a test has failed, or an API has started returning a server error. I mean, you can configure what kind of errors you want to be paged about, right? But you need to have some of these real-time alerts and monitoring set up for the entire engineering team to know of these issues as early as possible. So go back and make sure that your teams have the right sort of alerts, which can, tell them that, hey, problem is now, go and fix, right? Next is set up some basic health checks. Now, these are essentially, checks to make sure that the services are available all the times. Right? Health check means you'll hit an API, which will just return you a status code, which is 200, for example, right? And it'll show you that all right, the APIs are all up and running. So you need to run health checks continuously on your microservice and probably on the dependent microservices as well, right? So that you're always sure that whenever something goes down, you are aware of it, right? Your health check would fail. It would trigger some sort of a spike on your real-time alert system, and then the right people or the right set of folks, would get to know. Next is setting up a roster, right? I mean, you would have seen, right, that the entire team, they distribute their work based on features, based on quality, based on production support, and so on. Right? Why is that required, right? You need to have designated people who are looking at these failures upfront, or people who are accountable or made accountable, right, to make sure that your problems are addressed in time, right? So, I mean, think of a situation where your team is like on its own, and everybody is looking at the same issue at once, right? So counterproductive, and duplication of efforts. Or you leave it to anybody else, and then basically it just passes on and gets missed eventually. So you need to have very specific roster that, all right, for a week or for a sprint, there will be this person designated to make sure that all these alerts which are coming, all these health checks which are happening, they have an eye on it, right? And they're the first people to respond if there's anything that goes wrong. All right. Set up easily accessible logs, right? So, I mean, server logs, I think for all of us, are the first, solution when we are trying to debug something, right? Right. So we have to make sure that we are not only testing the application, but the logs are available. They're written when the application is developed, and then there are tools with which you can easily access those logs. I mean, for example, you would have heard of tools like Kibana or Grafana, which are Elasticsearch tools, which makes it easy to search logs on a server, right? But then there are so many paid tools as well. But whatever works for your team, right? Most important aspect here is the logging has to be very crisp. It has to make you reach the exception or the problem that is underlying, right? So that you can define the root cause and then eventually pass it on to the right person so that it could be fixed in time. So logging is supremely important with regards to monitoring how your microservice is behaving. Finally, tracking your API performance. Now, when I said API performance testing, right, there's a lot more you can do with regards to monitoring an API, right? Performance of an API means, what is the response time? What is, the throughput, right? And there's so many other parameters which you can fine tune using so many, API tuning tools, right? And you'll have to continuously keep doing that because the loads will keep changing, right, on your API servers. The density of key and value pairs that your API would also keep changing as the time move on, and you make your APIs bulkier, right, and so on. So make sure that you have some instrumentation tools that are helping you measure and fine tune your API performances. All right. Let me move to the next component into our operational quality strategy for microservices, which is production, right? I mean, we've talked about end-to-end testing, we've talked about white box testing, but still, right, on production, we need to have a minimal read-write flow, right? Why minimal? I mean, we want to have a lightweight prod suite which runs fast, because imagine that you have a production test suite which runs for 10 minutes. Right? If your first tests have failed, you get to know about it 9 minutes later. It's as simple as that, right? And 9 minutes, you would have impacted, I don't know how many customers, right? So make sure that you're identifying your production sanity in such a way that you are covering the most crucial APIs, or I think you can take some help from the data analytics and figure out what are the most used APIs or consumed APIs, where you can write some tests on prod, make sure they are working in tandem, right? And for doing some sort of production sanity testing, you'll have to set up your test data independent. Now, that means, because you're running a test on prod, that essentially could affect customers' real data, right? So you need to make sure that your data, probably you are creating it on the fly, or you are using something which is pre-existing, right? But that has to be independent, right, to any other data on production. Right? There are different ways of creating those sort of independent data. One of them is, partitioning your production in some components wherein your tests run into a specific partition, which is not the real customer partition on product, right? And then there could be other ways, like you identify your tests with certain sort of prefixes or suffixes, or you're using a very predefined customer to create all that data so that it is automatically ruled out from any tracking systems, right? And finally, you have to run your tests continuously with alerts, right? So production sanity is something that would probably run at the highest frequency amongst all your tests, right? They should run on schedule, which, I mean, we've used production test suites which run over, let's say, a minute and a half every 5 minutes. right? Because again, your purpose of production sanity test suite is basically to figure out, is there an impact on the customer, right? So you need to make sure that you run these continuously, and there are alerts set up, as we've already talked about, to make sure that you know about a problem upfront. There are a couple of don'ts as well with production sanity test suite, because I mean, it's eventually a test suite and we would like to do testing in a certain way. But there are a couple of don'ts which we've identified, which I'd like to share with all of you. With regards to product sanity, the first thing that you should take care of is not polluting your production with repeated test data creation. So unless you have a partition, which I was mentioning right now, unless you have a way which makes your test data clearly identifiable against your customer real data, and that this test data is not impacting the production servers in a way that a customer's data would do, right? You should be, keeping that data minimal. So while you have some read-write tests, you probably would be creating some sort of, entities on production, right? But because we want to run it at a very high frequency, we need to make sure that the data we are creating is not polluting or corrupting any other data on product. So it has to be very, very carefully done, right? The next is converting your production sanity into a regression suite, right? So, I mean, over a period of time, you'll have so many, features which keep coming in on your microservice in your system, right? And what will happen in the attempt of having just about minimal test suite, you'll end up having probably one test for each of the feature, right? And let's say if your system provides 20 features, you have a 20 test suite, 20 tests in a test suite, right? It's a big regression suite. I mean, you have other parameters like the time it takes to run them, the stability that they have, the alerts that they give on failures, and like that. So you have to be very careful into choosing your tests on the prod. Don't at all look to make it bulkier, because the whole purpose will be defeated, that you want early feedback. You will not get that early feedback, right? Plus, your tests could pollute, as I said, right? So rather than creating a large, huge suite, use some data, make some data-driven decisions, as we say. Find out what APIs are the most crucial ones consumed by the customers directly or indirectly, and probably create your minimal test suite based on that. So this is what product sanity test suite was. I think we have covered all the major components, and finally we come to the takeaways, which I'd like to spend some time on, because these are the most crucial information that you should take away from today's session, right? First one being adopt shift left. So people who face a lot of flakiness on their test environments, a lot of large end-to-end test suites, which takes hours and days to run, right? Probably, let's say, running on cloud and it's kind of not stable, and you're running on multiple devices, or if it's just API tests, probably context of microservices, long running tests, which are end to end, and they're dependent on third party responses, other microservices responses and all that, right? So you would always have some sort of flakiness because you can't control. So the answer to that flakiness is this shift left mindset, right? You leave nothing to be tested at a black box level. That is the idea. You test every scenario, every edge case at your integration and unit test layer. Basically, I'm making sure that the code that you're creating, it is the right thing, rather than eventually validating that has the right thing been built, right? So adopt this shift left mindset, start challenging, start questioning your setup, right? See what more tests we can do earlier in the cycle, right? So that the density of tests or the black box level, you can decrease that, and that will help you fight a lot more of flakiness. Probably you're not even adding flakiness to the pipeline in that sense. Next is quality must be baked in rather than put. So it's a mindset thing, right? It's a thing which you'll have to start thinking and practicing on a day-to-day basis, right? Earlier, when we used to have testing as a phase, all right, my story would come into the testing lane, and then I'll start testing. Gone are those days, right? With that, we are kind of trying to pour, quality on top. Everything has been built, and now we're just validating that things have been built right. We are basically trying to validate that, this quality, we can find bugs and fix them and make sure that our product is good quality. Now, the paradigm has shifted, right? We are so early in the cycle, we want to bake quality in, which means at every step, you want to do everything possible that results into a quality output, right? Which goes to the next step, right? As I said, shift left was about you start from requirements and reach to production with testing at each level, validating at each level in different ways. You can choose to have a lot more communication in terms of requirement validation. You can choose to have a lot more of white box tests with regards to units and integration. And then you might want to have some black box tests at the end-to-end production level as well. But the point here is you need to look at baking the quality into your microservices. If you leave it to the end, you'll always have bugs. SDET role is crucial for achieving quality goals. I think this is also one of the most important aspects of working with microservices. All of us would have the quality assurance thought process, right? The QA, right? We have the tester in our hearts, in our minds, right? But to be able to effectively do a lot of this white box testing, spanning over so much of engineering overall, we need to have competency of a dev as well. I mean, that doesn't mean that you have to start writing code for them. It's basically understanding technology just the way devs do. I mean, this is specifically for QA community who are looking to expand themselves into microservices testing, right? This is the time, start doing a lot more of engineering, start looking into a lot more of white box, all right? So be an SDET, right? So be a real software development engineer and use that in test. That's how your role should be, particularly for achieving your quality goals. Right, finally, a robust build promotion strategy is key to the early feedback. So you saw that CI/CD pipeline, which was explained by Preeti. So build promotion essentially means that the code which is right now in a dev's machine, how is that evolving to reach to the customer hands, right? So a build is basically getting promoted step by step and eventually lands on customers, right? So for us to have good feedback, early feedback, we need to implement a robust build promotion strategy, which means you have to clearly define how your CI/CD would work. You have to clearly define within each stage of your CI, what are the different checks, validations, tests, artifacts you have to create, right? And then pass it on to the next level. Of course, you have to keep the process lean and clean, right? And at the same time, that confidence that you're looking for, right, should be there. That will be there the more you practice on this, building the right sort of promotion strategy, right? For some of you in your projects, probably some of these activities may not be directly consumable, which is all right, right? Probably your service would need a little more of static checks than unit testing, right? Or vice versa. So go back, figure out what could be my best build promotion strategy, what different stages should I have? And accordingly, have your tests run in that pipeline. So one note for caution, we are running our automation on schedule using a lot of CI tools, right? So that is not what I'm meaning, what I mean here, right? It's about the delivery pipeline, which are created for the application. That same pipeline is applicable for the devs to check in their code, similarly for the tests to run. Unless a test validates that the code check-in is right, there's no value of automation that you'll get out. All right. So I'll leave you guys with these takeaways. Shift left, bake your quality in, be an SDET, and look for the best build promotion strategy in your microservice. What's up in our next session? So guys, in our next session, which will happen on 27th of April, we'll talk about these topics. We'll start with some of the testing tools and stacks for microservices. So we'll now from this session, we have set up the base on what sort of activities are required. How do you create a balance? What is the CI? What are the components? But now we'll not leave you here. We really want to deep dive a little more into best practices around white box testing, because it's probably would be new to a lot of us in the QA community, right? So we'll talk about testing tools. We'll talk about understanding white box testing even further in detail. We'll look at some of the best practices with all these white box testing strategies. So you saw unit testing, you saw integration, contract, static checks. So we'll look at how do we build these, right? And what are the best practices around them, which you can work with your devs in the team. I think the entire engineering team can work on it and probably churn out, better microservices altogether. And next time we'll also show a live demo on automating white box tests. So it'll be code, right? So we'll share some demo on how to write integration tests, right? All of you must have been automating black box tests for long, right? But now's the time that we start looking into white box as well. So being an SDET, that's where we have to grow, right? So we'll go do a live demo. We'll share some code. We'll try to explain the code components, right? And that should help all of you guys to start writing your integration tests. All right. So I think that is pretty much it that we have for this session. Great that we have completed within good time. We have time for Q&A. So we'll pick up from the questions that you guys have put down. All right. Let me read through. Okay. So I see that there are some of. I'll pick up the question. Okay. How do you deal with automated tests in case of flaky test environments? I think some of it we have already answered, because we are saying when staging or production or any of these live environments, there's so many components to take care of, right? I mean, your third party, I think it's written in the question as well, there are third party environments or external staging systems, right? In those cases, right, if we start doing shift left, right, you'll not find yourself into that problem, first of all, right? However, whenever you see flakiness, right, see, there's always this mechanism of going back to your tests, right? Making sure that, finding some pattern out of the flakiness, right? When you run your test continuously, right, let's say over a period of 1 month, right, you would have your logs available on the CI, right? And you check that, is my test flaky because of some sort of, code problem, or is just environment issues, right? Now with environment, you need to make sure that your environment is test friendly, right? I mean, devs should not lose confidence. I think that's the point, right? So if you have covered all your test scenarios within your integration and unit layers, right, not much would be left for you to be tested at an environment which is not under your control. So if you start doing that, you would see a lot less of this problem.
And just to add, right, in case if it's because of an external system which is not in a control and it's being flaky, I would say move to a testable strategy where you could actually, make use of stubs and mock and use of a stubbing or a mocking technique and test at least your own service is behaving as expected or not. And you could still test these two systems in isolations and you can get most of the results.
Yeah. Okay, we have one more question. It's about understanding more of linting and quality gates on PRs. So we definitely have both of them covered in our next session. We're talking about linting and how do we implement those on quality gates. So do watch out. But just to answer you, quality gate is largely a concept. It's a concept which basically makes you configure some of the rules on your PRs, that if those rules are not met, your PRs will not be allowed to be merged, right? So that is what we call as a quality gate. You basically have some quality parameters. For example, my code coverage should be 80%. If you raise a PR, and if that's, your scanner finds out that, oh, after this PR, your code coverage drops down to 79%. Your quality gate will not pass. Basically, it will not be met, and it will start reflecting that you cannot merge this PR. So that is what quality gate means. Linting is more of a static. I think it's more of a code standard tool. I mean, a tool which will help you adhere to certain coding standards, coding rules that you yourself can define. For example, I don't want unused variables. So you can use some of these linting tools which will scan your code and will give you a report that, okay, amongst entire code, these are the lines where you've used unused variables, for example, right? So we'll talk more on these in detail in the next session, but I hope this would have helped. Do we have another question? Just trying to find out. Okay, there's one more. Regarding tests, regarding test coverage, how do we ensure that automated tests written by QAs or SDETs cover all the test cases that are implemented in application code? All right. So first of all, we have to understand the difference between test coverage and code coverage. Right? Code coverage comes from the unit tests. Right? It basically the source code, and you write some unit tests and make sure that your unit tests are covering branches and conditions in your code. That'll give you a code coverage, right? Which is completely in the hands of people who are writing unit tests, who are directly having a kind of a white box interaction with your system. Test coverage is more of validating whether all acceptance criteria, all use cases have been converted to test cases, right? Which you might want to execute manually or in an automated fashion. Right? So how do we ensure that these cases primarily by, as I said, right, primarily by comparing your test cases against the acceptance criteria. I mean, with regards to test coverage, right? You have to make sure that and particularly with microservices, we add all the tests within the microservice code base itself, right? It shouldn't be that you have a separate test automation repo, right? Ideally, all your tests for a microservice would reside in the microservice itself. Which means when you're converting those ACs or acceptance criteria into tests, you basically add them into your automation, you raise a PR and have a strong PR review for process that will help you cover and ensure that all these cases are covered. All right. Is there any other question? Okay, I don't see. There's no open question. Okay, there's some of them which have already been answered. Great. Okay, so we are in time. I guess we'll wait for just one more minute. If there are no more questions, then we can wrap up today. And we hope that you guys, enjoyed the learning today. Right, we'll have the next session. If there are any questions, if you come up, probably when you retrospect on the session, go back, have your question and ask them to us in the next session. We'll be all open to answer all of them. All right. Great. I think then if there's no more question, we can drop. We can wrap up. Cool. Thank you so much, everybody, for joining on this Thursday evening. We'll see you next Thursday. Bye-bye and take care.